All right, welcome back today. These are your warm-ups today. We're kind of getting a little more complicated with it. A couple multi-step problems and solving for x here using the Pythagorean Theorem. Same theorem still. It's there. You guys know that theorem by now, hopefully. So you guys would walk through and solve a couple of these, and let's get started. All right, so when we look at this one, we can see that the 5 is our hypotenuse right here. It's opposite the 90 degree. And we got two legs. X squared plus 3.2 squared equals 5 squared. X squared stays x squared. 3.2 squared, once we kind of push that out, we're going to come up with 10.24 equals 25. And subtract that out, we get x squared equals 14.8. All right, and I can't really do much with that. I could take the square root and give you the square root, but for time's sake, we are just going to leave it as the square root of 14.8. All right, and that is our distance there on that height of this triangle figure. Next, looking at this one. This one's a little more difficult because it doesn't tell us to directly find this height, but in order to solve it, we need to directly find this height. All right, we can make an assumption that it's going to be that 10.2, but we don't know that for sure. So it's important that we kind of take a look and see. They don't give us any measurements here. So the way we have to do this is we have to go out and set it up as two triangles. The first one's going to be 10.2 squared plus x squared equals 13. All right. Once we solve this out, 10.2 squared is going to be 100. It's going to be 104.04 plus x squared equals 169. All right. Take that away from both sides, the 104.04 and the 104.04. That's going to give us x squared equals, what does x squared equal for us? It equals 64.96. All right, and we could take the square root there and take the square root, and we get x equals, square root of that is about 8.1. So we now know that it's not 10.2. Well, we don't really necessarily know that, but we know that the middle is going to be 8.1 tall, right? Which falls below the hypotenuse, so things are looking good still. Now we can plug in that 8.1, plus x squared equals 13. And as we do that, you can see that it's ultimately going to be the same equation. We're just doing a different thing here. So we should come up with 10.2 as our final answer. Now, you should show the work to kind of get there because you can't make assumptions. But once you set up that problem to be the same way as it was, you need to be able to show it and make that decision quickly. Right, and anytime we're rounding, the numbers might not come out exactly even, so that's kind of where it's on you to realize that we're using Pythagorean Theorem and the distributive property and the different properties that we've covered throughout our math careers. All right, this one's asking for two parts here, x and y. So when we take a look, we have to kind of figure out either one first. It doesn't really matter. They're not relying upon each other, but it could just be something that we need to do. So we know it's not in the middle just by the way that it's drawn, so we're not going to even assume that this time. So we're going to go 12 squared plus 25 squared equals x squared. 12 squared is 625. All right. 25 squared is 625. The 12 squared is 144, and that equals x squared. Add those two together, we get 769. 769 equals x squared. Take the square root of both sides. The square root of 769 we're going to leave as the square root of 769. All right, and that equals our x. Not x squared, just our x. Okay, now that's some decimal there. And ultimately, we could probably simplify it to something along the lines of 75 and square root of 13, maybe, or something along those lines. Don't quote me. I'm just doing this in my head. But it's probably simplifiable, but for time's sake, I'll let you guys simplify it on your own for good practice. Now, last but not least, we're not done yet because we have to solve for y, so we're going to take 12 squared plus y squared equals 14 squared. And as you guys work through that problem, you should come up with, again, 144 plus y squared equals 196. All right. And when we look at that, we take those away. Y squared equals about 52, I believe, or 50. 52. And we could simplify that out in a way and see if anything comes out. But again, I'll let you guys do that on your own. We'll leave that as 52, square root of 52. That's how you would solve something like that. Now this one, again, it's the same idea. We want to know basically what is x, which means we have to figure out what this bottom leg is out of 12. So what we have to do is we have to take our 6 squared plus our x squared equals 110 squared. Jumping ahead, 36 plus x squared equals 100. Subtract 36, subtract 36. X squared equals 64. X equals 8. All right, so now we know that that's 8. We know that this is 4. So 4 squared plus 6 squared equals x squared. 16 plus 36 equals x squared. And we get the 52 on this side again equals x squared. Take the square root of both sides. Square root of 52 is square root of 52 for our purposes. We'll leave it there. Now you will have to simplify that. You can go through the factors and kind of see what it is. Probably 13 and 4, so 2 to the square root of 13 would be the final answer there, I believe. Again, did that without taking a lot of time. So if I'm wrong, bear with me. Last one, you guys get the idea. I don't think we need to solve this one, do we? We'll skip it, but that's kind of your last one today. Well, no, we'll solve it because it is kind of your last one today. So let's make sure we show you how to do this, okay? First and foremost, we need to solve for what this little length is right here. So the best way for us to do that is go 3 squared plus x squared equals 5 squared. And I know I'm using x and it's over there, but I'm kind of keeping track in my head that they're not the same x. All right, so I get 25, oops, excuse me, 9, wow. Let's go back a step. Here we go. Back it up, back it up, back it up. There we go. 9 plus x squared equals 25. X squared equals 16. All right, x equals 4. So we know that this side now is 4, which makes this side 7. So when we go to solve this x, we're actually going to go 3 squared plus 7 squared equals x squared. All right, 9 plus 49 equals x squared. 56 equals x squared. You know, when we look at 56, we can definitely simplify 56 down. You know, to get kind of started with it, we know that's 28. 28, we could take the 28 times 2, so that's there. But if it's 28, it might also be 14 times 4, right? 14 times 4 if we did that. Except for I did my math wrong, nobody called me on it. It's really going to be 57, which we know there's no square root for, so x equals the square root of 57, and we'll leave it there. If it was 56, it'd be a different story, but it's not. Again, a reminder on simplifying your radicals. Make sure that you guys are going through and doing this. All right, find the factors that lead into it. All right, and find the factor with the perfect square. Right, some of the factors will have a perfect square. Sometimes there'll be more than 2. So if you do it one step, make sure there's not another step for you guys to take. All right, so 25 times 2 is the factor. All right, and then we get, again, down to that simplified form. I want to thank you guys for watching. Tomorrow we're going to be taking a look at special right triangles. We'll have some notes to go along with that so that we can get our work done in an orderly and meaningful fashion. Again, thanks for watching. Take care. We'll see you.